So the next lesson we are learning in this module under Unit 2 would be Module 1.2. And today we are going to learn about tables of equivalent ratios. This is Module 1.2. So if you can see our learning target, I can represent a collection of equivalent ratios and show the ratio relationship between two quantities using tables of equivalent ratios and double number lines. So the vocabulary that we will be learning in this is a double number line, equivalent ratios, ratio table, and scaling. All right. So let's begin with a question for which I am going to take you here so that you see the question better. Here we go. All right. So the table shows the ingredients needed to make the dough for one pizza. You use this information in an activity earlier, but anyways, we are going to look at how can we find an equivalent ratio for this, okay? So we can see that for the ingredients, we have Greek yogurt. We need 2 cups of that. And we have the self-rising flour, which is 3 cups of that. And this makes one pizza. So we want to see that how much of the ratio needs to be maintained of 2 to 3 when we are making 1 pizza, 2 pizzas, and 3 pizzas. All right. So the best way I can quickly show you first with a bar diagram. So let's look at this. First, let's see what is an equivalent ratio. An equivalent ratio is a ratio which expresses the same ratio relationship between the quantities, okay? So same ratio relationship. So let's go ahead and, we said that we need 2 cups of Greek yogurt. Okay, so 2 cups of Greek yogurt. And we need 3 cups of self-rising flour. 3 cups of flour. And this is for 1 pizza. These were the ingredients that are provided to us. So if I'm looking at this, I'm going to see that my ratio is what? 2/3, right? So I can always write it like this, 2 to 3. That is the ratio that needs to be maintained for how much? For 1 pizza, okay? So if I create a bar diagram for this, for my Greek yogurt, I have 2. So I have 2 of yogurt, okay? This is 2. All right, this is my yogurt here. And I have 3 parts of flour. So 1, 2, 3, and this is my flour. And if I'm looking at this, each of this is 1, right? This is 1, 1, 1, 2, 3. So my flour is 3. So here's my ratio of 2 to 3. This is for 1 pizza. All right. So we need to maintain the same ratio for 2 pizzas, for 3 pizza, etc. So I'm just going to show you with a bar diagram. And if this is for 1 pizza, for 2 pizzas, what do I need to do? So I'm just going to take the same amount. I'll just make it here. All right. So we have yogurt and 2 parts. And then we have flour. 3 parts, that's my ratio, right? Now, for 2 pizza, I am just going to do what? I am going to double the amount, okay? So, I am going to now, instead of 1 and 1, I'm going to put 2 here because it should be equivalent, right? So now, if I'm looking at this, what do I have up here? I have 4 of the yogurt, and I have 6 cups for the flour, okay? So as I can see that this ratio is being maintained, 2 to 3, so this one is going to be 4 to 6, and this is for my 2 pizzas. This is for 2 pizzas. Okay, this is for 2 pizza. All right. Then let's look what happens if I need 3 pizzas. Okay, for 3, again, I'm going to take the yogurt, we take the flour, okay, and I'm going to put the same equivalent 2 to 3, that's what it was earlier, right? And now we are going, this is for 3 pizza now. So I am going to triple that recipe, right? Or triple the ingredient content. So that gives me 3 in each section. So what does it become now? This is 6 now. 3 times 2 is 6. And this becomes 9. 9 cups of this. So what is my ratio? This is 6 to 9. All right. So now when I'm looking at all of these ratios here, if I have 2 to 3, I have 4 to 6, I have 6 to 9. Okay, all of these are equivalent ratios. These are all equivalent ratios. Okay, these are all equivalent ratios, and because they express the same ratio relationship between the quantities. So that's basically what equivalent ratios are. Okay, so a table of equivalent ratio or a ratio table, this one, okay, a ratio table is a collection of equivalent ratios that are organized in a table. And each column consists of a pair of quantities that have the same ratio as the pairs of quantities in the other columns. And so I'm just going to show you the same thing in a ratio table, and I'm going to just make it up here. So we're talking about Greek yogurt. I'm just going to do this. Okay, so this is my Greek yogurt. And this is my flour. Okay, so if I am looking at how many cups I need, you can see that we had started with the ratio of 2 to 3. This is 2 yogurt to 3 cups of flour. And then we said, when I showed you this, look, this is 4 to 6. And then this is 6 to 9. So when this ratio is shown in the form of a table, this is a ratio table. It's a collection of the equivalent ratios that are organized in a table, okay? And so in the ratio table shown, the ratios 2 to 3, 4 to 6, and 6 to 9, these are all equivalent. This. All right? And so basically what am I doing? Ratio tables, they are showing both an additive structure and a multiplicative structure. Okay, so if I look at the pattern, what's happening over here? So an additive structure because I am adding 2. I am adding 2 over here in this case. All right, so that is showing me an additive structure. All right, and in this case, what am I adding? I'm adding 3, so I'm looking at that pattern. Okay, so this is an additive structure. Okay, this is an additive structure. And then when I'm talking about multiplicative structure, that basically means that I am multiplying each of the original quantities by the same number to obtain the values in each of the other columns. So if I say multiplicative, okay, let me use a different color to show you. What is this? This is times 2. Whatever I do to the numerator, I do the same thing to the denominator or to the ratio. So if I'm doing times 2 there, I'm doing times 2 there, right? What is 2 times 2? 4. What is 3 times 2? 6. Okay, then let's look at the next multiplicative structure. Okay, what is 2 times 3? That gives me 6. So whatever I do to the top part of the ratio, same thing to the bottom. Here you go. If I do times 3, 3 times 3 gives me 9. So when I have this is, because I'm multiplying each of those, this is called the multiplicative structure. Okay? Multiplicative structure. All right. So I showed you how you have an additive structure or how you have a multiplicative structure. And so the process of multiplying each quantity in the ratio by the same number to obtain an equivalent ratio is called scaling that we were talking about. Okay? And so again, once again, let me explain that. The process of multiplying each quantity in a ratio by the same number to obtain an equivalent ratio is called scaling. And you can use scaling to extend the ratio table to find the number of cups of each ingredient needed to make additional pizzas. By doing so, you find more equivalent ratios. So if I had added on to this and I had added on to the table, and if I was like, okay, if I do this, all right, all I would have to do is what? I would have done 2 times, this was 3, so 2 times 4 is going to give me 8. All right, and then same thing, 3 times 4 over here, and that is going to give me 12. So I can keep adding on to the table like that. Okay, and this is called scaling, and this pattern will continue like this. All right, and so if I take the next one, it would have been 2 times 5, and I would have got a 10 up here, and 3 times 5, I would have got a 15. So to make 4 pizzas, you will need 8 cups of yogurt and 12 cups of flour. To make 5 pizzas, you will need 10 cups of Greek yogurt and 15 cups of flour. And so again, all these ratios, the ratio 8 to 12, 10 to 15, these are all equivalent to 2 to 3, 4 to 6, and 6 to 9. All right, and so let's talk about another example now. And we are going to use scaling in order to solve this. Okay, so let me take you to the question. Here to use the question, and here we go. All right, so it is saying to make, and we are going to scale forward in this one. To make yellow icing, Amira mixes 6 drops of yellow food coloring with 2 cups of white icing. How many drops of yellow food coloring should Amira mix with 8 cups of white icing to get the same shade of yellow? So what we're going to do, we are going to create a ratio table with the information that we have. Okay, so we are going to create a ratio table with this information that we have, and here we go. So if I create a table, let me use this color, which you can see better. All right. So I'm going to create a ratio table with the information that I have. So let's see, what do we have? We are talking about yellow food coloring. Okay. So food coloring. And we are talking about the icing, okay, white icing that is required. All right, so we're going to see what are we creating a ratio of. All right, now we are given that for every 6 drops of yellow food coloring, there are, so for every 6 drops of yellow food coloring, there are 2 cups of icing. 2 cups of icing. All right. And so then it's asking, the unknown number, which is the number of drops of yellow needed to mix with 8 cups of icings. This is what we don't know, but we have this. Okay, so when we are going to do this, we are going to scale forward because we are going to find how many drops of yellow does Amida need to mix with 8 cups of icing. So when I'm talking about scale forward, I need to see that 2 times what is going to give me 8. Okay, so I know that 2 times 4 is equal to 8. So whatever I do to the bottom ratio, I do the same thing to the top. So I do 6 times 2. Sorry, 6 times 4. Okay, because this is times 4, so this is also going to be times 4. All right, and so what is 4 times 6? I'm going to get 24. Okay, so because 2 times 4 is equal to 8, we're also going to multiply 6 by 4 to obtain 24. And so the ratios 6 to 2 is equivalent to 24 to 8. All right, so these are equivalent ratios. So Amida should mix 24 drops of yellow food coloring with 8 cups of white icing to get the same shade of yellow. All right, so this was scaling forward. We can also write it like this as an equivalent ratio. 6 over 2 is equal to how much over 8? We're trying to find the unknown amount. Okay, if I'm putting it as an equivalent ratio. So along with the table, I can also write it like this. All right, and I know that 2 times 4 gives me 8. Whatever I do to the denominator, I do the same thing to the numerator. So 6 times 4, and that gives me my answer that I should have 24 drops of the yellow food coloring. To create an equivalent ratio with 6 over 2, it will be 24 over 8. All right, so that's another way I can show it, the ratio table, or writing it out like this. Okay, let's do another problem, and let's look at this. In this case, look at the question. It is saying Aquino mixes 3 sample containers of yellow paint with 4 sample containers of red paint to create his favorite shade of orange paint. His little sister Echo wants to create the same shade of orange paint, but she only has 2 sample containers of red paint. What should Echo do to create the same shade of orange paint? All right, so in this case, we can see that we will have to scale backwards to find the equivalent ratio, because in this, again, we are seeing that we are going to create a ratio table with the given information. All right, so we are going to create a ratio table. And let me use the black color. So I'm just going to create the ratio table up here so you can see what I'm doing. All right, there's my table. And we are going to put it like this. All right, and this is my yellow paint to my red paint, what I have. Okay, and so I can see I have 1, 2, 3. So this is my 3. Okay, so I'm going to make a ratio table. I have 3, and I have 1, 2, 3, 4. This is 4, right? So 3 to 4 is what I actually have. All right, but now I know that for every 3 containers of yellow paint, there are 4 containers of red paint, and the unknown is the amount of yellow paint needed to mix with 2 containers of red paint. So because she only has how much? She only has 2 containers of this. All right, so in this case, I'm going to scale backwards to find the equivalent ratio. So that means I'm going to have to divide, and then I'm looking at 4 divided by what is going to give me 2. So what am I doing? I am dividing by 2. Okay, and look over here. Whatever I do here, I have to do the same thing over here. So I've got to divide 3 by 2 also, and I'm going to get, what is half of 3? It's 1 and 5/10. Okay, so 1 and 5/10. So this is called scaling backwards. Okay, so as you can see, we have that because 4 divided by 2 is 2, we are going to divide 3 by 2, and we get 1 and 5/10. And the ratios of ratios 1 and 5/10 to 2 is equivalent to 3 to 4. And Echo should mix 1 and 5/10 containers of yellow paint with 2 containers of red paint to create the same shade of orange paint. But that's how you calculate your equivalent ratios. I can also do it this way, scaling backwards. Remember, scaling forward, you're multiplying. Scaling backwards, you are dividing, okay? Because the number is getting smaller, that's why it's backwards. Forward is getting bigger, so that is why you are multiplying, all right? So I can also do it like this. I can write out an equivalent ratio. 3 to 4 is equal to how much over 2? So if I write it as an equivalent ratio, this is equal to this. So I'm saying, how do I get that 2? What have I done? I have divided by 2. Whatever I do to the denominator, I've got to do exactly the same thing to the numerator. So divided by 2, and I get 1 and 5/10 of the yellow paint to 2 of the red is the same ratio as 3 over 4. But that's how I can also show it. Along with the table, this is another way to show equivalent ratios. All right, so let's do one more problem, and in which I want to show you that you can scale backwards and forward on the same question. All right, so let's look at this one. And in this we can see, this is an example in which we are going to scale in both directions. All right, so the question is saying, Natasha made raspberry punch for a party by mixing 9 fluid ounces of fruit punches, 3 liters of soda, and 6 scoops of raspberry ice cream. Halfway through the party, the punch bowl was empty. If Natasha only had 6 fluid ounces of fruit punch left, how much ice cream does she need to make another batch of punch? Okay, so let's look at what she needs to do. We are talking about for every 9 fluid ounces of fruit punch, there are 6 scoops of raspberry ice cream. So remember what I had talked about earlier in class is that always look at the question. Don't jump at the numbers, because there might be some given there that you don't need it, or you might be reading the ratio backwards. So first you got to look at what the question's asking. All right, so talking about fruit punch to ice cream, and that's what. Do we need soda for this part of the question? No, because it's only asking for the ratio of your how much of the fruit punch, the fluid ounces of fruit punch to your scoops of ice cream. Okay, so those are the two numbers that we need to look at. All right, so we are going to go ahead and create a ratio table with the given information. So I'm just going to create it like this. Again, let me use black color because that is always visible the best. So I'm going to make a ratio table. All right, and go ahead and do this. And we are looking at the fruit punch fluid ounces, all right, to the ice cream scoops, all right. And then it's saying that we had 9 to 6. So I'm just going to do this. All right. We have 9 fluid ounces of fruit punch to 6 scoops of raspberry. That's what I need to look at. This to this, because this is what we're talking about. All right. And there is no whole number by which you can multiply 6 to obtain a product of 9. So because we are trying to find what? We are trying to find over here that she only had how much left? 6. So I'm going to write that here. Okay? I'm going to write that here. And it's asking how much of ice cream should I have? That's basically what the question is. Okay? So since there's no whole number by which you can multiply 6 to obtain a product of 9, because what I'm going to do is I'm going to scale backwards to find an equivalent ratio. So let's look at this. I do have 9 and 6. So look, if I do this, look, I'm showing you another way. They are both divisible by what? 9 and 6 are both divisible by 3, right? So if I divide by 3, and if I divide by 3, what equivalent ratio do I get? I get 3 over 2, 3 to 2. And so what am I doing? Because I'm dividing, I'm scaling backwards. Okay? So look, I'm going to scale backwards. And I'm dividing by 3. Okay, dividing by 3, and I get 3 here. And then I have to do the same thing down here to this ratio. I'm dividing by 3, and I'm getting 2 here. Okay, so first I scale backwards. I scale back. All right, and once I've scaled back, I can now go ahead and scale forward. Okay, because I'm going to use the equivalent ratio I found to scale forward to find the desired equivalent ratio. So let me use a different color. Let me use blue to show you. Now that I have 3 to 2, I can scale forward. That means I am going to multiply, because 3 times what gives me 6? 3 times 2 gives me 6. Right? 3 times 2 gives me 6. So whatever I do to the top, I do the same thing here. This is times 2. And what is 2 times 2? This unknown value is going to be 4 ice cream scoops. Okay? So this is called, this going forward, this part is called scale forward. This is scale forward. Okay? So sometimes I have to first scale back, and then I have got to scale forward to find the equivalent ratio. So this results in the equivalent ratio of 6 to 4. So 6 to 4 is the same thing as 9 to 6, is the same thing as 3 to 2. All right. So Natasha should mix 4 scoops of raspberry ice cream with the remaining 6 fluid ounces of fruit punch. All right. And then let's just do one last problem by using a double number line to find equivalent ratios. Okay. Okay, I'm just going to go and do it over here. So let's talk about a problem. And here's the question. All right, so we are going to use a double number line to find equivalent ratios. We are making homemade biscuits, and the ingredients needed to make 24 biscuits. All right, so for 24 biscuits, you have a entire chart of ingredients, but basically what we are going to talk about is how much of we need for like 24 biscuits. We have 4 cups flour. Okay, so we have 4 cups flour. This is what we are going to focus on, but we have 8 teaspoon baking powder. Okay, 8 teaspoon baking powder. We have 2 tablespoons sugar, 2 tablespoons sugar. This is, sorry, 2 tablespoons sugar. We have 1 teaspoon salt, 1 cup shortening, 2 large eggs, 2 cups milk. So I mean, basically all the ingredients are listed here. But I'm not going to write the rest down because we are only going to focus on what the ratio has been asked for. And so it's saying these are the ingredients needed to make 24 biscuits as shown over here. And if Portia wants to make only 18 biscuits, if she wants to make only 18 biscuits, all right, if she wants to make only 18 biscuits, how many cups of flour does she need? So that is why I didn't write all the rest of the ingredients down, because right now we just need to focus on biscuits and how much flour. So we are going to use a double number line to solve this problem. And a double number line consists of 2 number lines in which the coordinated quantities are equivalent ratios. So I'm going to draw a double number line. So this is the number line. Okay, this is the 2 of them. One is going to represent the flour, how much flour I need, and the other one right under it, this is going to represent how many biscuits I can make. How many biscuits can I make? All right, so that is what a double number line looks like. And to make 24 biscuits, Portia needs 4 cups of flour. Okay, so we are starting here, and so she needs how much? She needs 4 cups of flour. So this is what I'm going to do. This is 4 cups of flour for 24 biscuits. Okay, to find the equivalent ratio, we are going to scale back, and you can divide both 4 and 24 by 4, right? You're finding an equivalent ratio. And so this results in the equivalent ratio of 1 to 6. So since this over here, we have 0 here, right? And then this is going to be here. And this is exactly what I do. I'm dividing 4 by 4 and 24 by 4 to create an equivalent ratio. And I get 1, 2, 3, and 4 like this. All right. And what is each part going to be? I'm going to divide the bottom number line into increments of 6 units, because 24 divided by 4 is what? So I get 6, 12, and 18, right? And then the value of the top, now the top number line that corresponds with 18, because we are trying to see how much for 18 biscuits. So for 24 biscuits, we needed 4 cups of flour. So when I'm looking at 18 cups of 18 biscuits, we need 3 cups of flour. So that's what my answer is going to be in this case. All right. But that is how we use a double number line in order to calculate this. All right. So this is basically what my lesson is on finding equivalent tables of equivalent ratios, and how to scale backwards, how to scale forward, what are equivalent ratios, how to create a ratio table, and how to create a double number line. Right? Have a great day, everyone.